Miss Norris here, and I'm going to walk you through some examples of solving rational equations. These examples that I'm going to go through, and there will only be one example per video because I'm not a videographer or a YouTuber or anything like that, so I honestly have no clue what I'm doing in terms of this. I realize the lighting is bad, and that's because it's a little after 10 o'clock at night, and I tried setting up a light and it just like bounced off of the whiteboard here and created shadows. And so anyway, I'm just going to do the best I can, which is probably how you all feel about your online learning. Okay, just doing the best we can. So before we get started, I do want to say that I hope that you and your families are all healthy and well, and getting through this as best as you can every day. And I also want to say that I miss you. I miss being in the classroom surrounded by your mostly positive energy and your smiles. I miss when you do goofy things and I get to throw shade at you. So anyway, there's not going to be anybody in this video to throw shade at, so I'm a little disappointed in that. Maybe I'll throw shade at myself. You know, I've told you before, I don't embarrass easily. And this entire video will probably be an embarrassment. And quite frankly, I've already attempted to record it several times. And there was an entire portion of the whiteboard in my work that you couldn't even see. So that is why it's 10 o'clock at night. And let's see if this one actually works. So we are solving rational equations, and rational equations are just equations that have rational expressions in them. And we've been dealing with rational expressions for a couple of weeks now and doing all kinds of operations with them. So, but those were just expressions. It didn't involve solving anything because it wasn't an actual equation. Now we have an actual equation that we're going to solve because we have an equal sign. Okay? So if you look at the notes that I provided to you, step 1 says to factor all the numerators and denominators if necessary. Well, in this particular example, there's no factoring needed because there's no quadratics, there's no common factor here in this binomial, nothing like that. So we're going to basically skip over step 1. We're going to go on to step 2, which says to establish the domain restrictions. Or there could be just one domain restriction, who knows? But in this case, in example 1, we have 2 domain restrictions that we need to account for, okay? After the equation, I normally write, okay, yes, I normally go ahead and write a semicolon here, okay? And then I'm going to go ahead and state the values that x cannot be equal to, okay? So keep in mind we're establishing domain restrictions because we're stating the things that x cannot equal. And normally with rational equations, that means what values of x would actually make the denominators equal 0 and thus make those expressions undefined. Well, if x was equal to 0 here, that would make this ratio right here undefined. So x cannot equal 0, okay? If x was equal to -2, that would make this entire ratio undefined, and therefore x cannot equal -2. Okay, so x cannot equal 0 and it cannot equal -2. We have finished step 2, which was to establish domain restrictions. Now let's move on to step 3. Step 3 says to eliminate all denominators by multiplying both sides of the equation, meaning every single term, by the lowest common denominator. We all know that you guys hate fractions, and we got fractions here, and the way we're going to get rid of those fractions is by multiplying by the lowest common denominator so that we can cancel out the denominators altogether. The very first thing I'm going to do is rewrite my equation of 3 over x plus 5 over x plus 2 is equal to 2. I'm going to put a bracket around the entire equation, and I'm going to show on the outside of those brackets my lowest common denominator that I'm going to multiply by. Now, the lowest common denominator is normally found by just multiplying any or all of your denominators together. So this x times this x plus 2 needs to be multiplied together as our lowest common denominator. So x times x plus 2. And I'm showing that on both sides of the equation, okay? I'm now going to take that LCD, the lowest common denominator, and multiply it by every single term in the equation. which means on the left-hand side here, I've got a 3 times that x plus 2, and the whole thing is over x. Okay, bring down the plus sign. This 5 is also being multiplied by that x and that x plus 2. So I've got 5x times x plus 2, and that's over x plus 2. And now on the right-hand side of the equation, I've got this 2, and that 2 has to get multiplied by the LCD as well. So the 2 is getting multiplied by the x and the x plus 2. Okay? So that is step 3, okay, is to multiply both sides of the equation by the lowest common denominator. This is what's going to allow us to eliminate all the denominators. This denominator of x cancels out because there is now an x on top. So the x's go away on the top and bottom. There's an x plus 2 on top here and an x plus 2 on the bottom here. Okay, so those eliminate as well. And that leaves us with a 3 times x plus 2 plus 5x is equal to 2x times x plus 2. Okay? Now, I need to go ahead and move this a little bit so you can see the rest of this, because I am tired of filming the same video like 8 times at this point. Anyway, so now we're moving on to step 4, which says to solve for the variable. Okay, we want to solve for x. Now, in order to solve for x, the very first thing we need to do, and hopefully you see this, is we need to distribute this 3. So 3 times x gives us a 3x. 3 times 2 gives us 6. I'm going to bring down that plus 5x equals, and now I'm going to distribute this 2x. 2x times x gives us 2x squared, and 2x times 2 gives us a positive 4x. Okay? Now I'm going to combine like terms that are on the same side of the equation, which means I'm going to combine this 3x and this 5x. That gives me 8x plus 6 is equal to 2x squared plus 4x. I can see I've got a quadratic, which means at this point I want to get all of my terms on the same side of the equation and to get it set equal to 0. Okay? So on the right-hand side, I'm going to put my 2x squared in the front because it's my highest degree term. I've got an 8x over here, but I got to move across the equal sign, so I'm going to subtract 8x from 4x. That gives me negative 4x, and I'm going to subtract 6 to the other side as well. That leaves me with 0 on the left-hand side. And the reason that I moved everything to the right-hand side instead of the left-hand side is because my coefficient on the x squared term, meaning the a value, was already positive. So I want to keep that positive because that makes it easier when I'm solving the quadratic, and therefore I left it on the right-hand side. Now, when I look at all the terms in this quadratic, I see that they all have a common factor of 2, so I'm going to pull out that common factor of 2. So I've got 0 is equal to 2 times, when I factor the 2 out of the 2x squared, I get x squared. Factor 2 out of this, I get a negative 2x. And factor the 2 out of the negative 6, I get a negative 3. Okay? Now, the reason why you always want to factor out a common factor is so that your quadratic is in its simplest form. And this is its simplest form, and in fact now our a value is equal to 1, which is the simplest type of quadratic to factor. So I'm going to go ahead and set myself up to do that factoring. So I have 0 is equal to 2. I'm going to set up my parentheses for the factoring. Of course, our x squared factors as x times x. The two numbers that multiply together to give us 3 are 3 and 1. Because the last term is negative, that means that your signs have to be opposite, and you look at your middle term to determine which one goes where. So a negative 3 times a positive 1 gives us a negative 3, and a negative 3 combined with a positive 1 gives us that middle term of negative 2. Okay? All right. Now, I'm going to go ahead and take each one of these factors and set it equal to 0. So I've got 0 equals 2, which obviously it does not, which is why it did not matter that we pulled out that common factor of 2. I've got x minus 3 equals 0. And I've got x plus 1 equals 0. And now solve for x. I've got x equals 3 here, and I've got x equals negative 1 here. Okay? Now, that makes us feel like we've accomplished what we needed to do. And in normal circumstances, this would mean that we had. However, in solving rational equations, the act of multiplying both sides times that least common denominator of x times x plus 2, that can do funny things. It can make us come up with what's known as an extraneous solution. Okay? So, we have to, now that we've solved for the variable, which is step 4, we have to now move on to step 5, which says to check your solutions. Before you box them, you need to check them. Okay? Check your solutions against your domain restrictions, and check them in the original equation if they're not part of your domain restrictions. So this is what this means. Okay, we got answers or solutions for x of 3 and -1. Now, our domain restrictions up here were 0 and -2. So neither one of our solutions is one of those domain restrictions. If it were, we would just go ahead and just cross it out as an extraneous solution. Okay, but because neither one of our solutions that we just got were one of our domain restrictions, that means we have to test them back in our original equation. Okay, and so that is what I'm going to do now. Okay, I'm going to take this x minus 3, and I'm going to test it back in the original equation by plugging it in. Okay, the good thing about this, even though it's extra work, the good thing is that you're actually checking your answers before you submit them. Okay, so let's take x equals 3 and plug it back in. I'm going to write this over here, and there we go. I'm checking x equals 3 back in my original equation. My original equation is 3 over x, but I've got an x value of 3 that I'm testing here. So I've got 3 over 3 plus 5 over x plus 2. So I've got 3 plus 2. And I'm asking myself, is that equal to 2? Well, 3 over 3 is 1. 3 plus 2 is 5, and 5 over 5 is 1. And of course, 1 plus 1 does indeed equal 2. Okay? And that means that 3 is a good solution for this particular equation, and I'm going to go ahead and put a box around it. Okay? Now, hopefully you can see down here, I'm going to go ahead and check x equals -1 right here. Okay? All right? So, bear with me. There we go. Okay, so I've got 3 over x, so that means I've got 3 over -1 plus 5 over x plus 2, so that's -1 plus 2, and I'm asking myself, is that equal to 2? Okay, so 3 over -1 is a -3, -1 plus 2 is a 1, and 5 over 1 is just 5. And of course, -3 plus 5 is 2. So I have that 2 equals 2. This solution also checks out. So I'm going to go ahead and put a box around it. Okay? And all of this work is required in order to solve rational equations.